All right, this is Mrs. Bettis back with part 2 of our section 7.5 on solving exponential and logarithmic equations. So the second part is solving the logarithmic equations. Part 1, if you didn't watch it, was on solving the exponentials, but this is going to be for the logarithmic equations. So before we start, I just want to remind us that, remember, exponentials and logarithms are inverses of each other, and we will be using that fact to help us solve these equations. Along with that, we need to recall our properties of logs that we learned about a month ago in class. So hopefully these examples jog your memory, and at the end I'll give you some to practice on your own. Okay, so let's get started. Problem A, it says solve. Now this time we're not going to check them like we did with the other examples, but we're just going to solve them and move on. Here I have log base 3 of a quantity x minus 5 is equal to 2. And what we're going to do is similar to what we did with the exponential equations, is we're going to take good use of the fact that exponential equations and logarithmic equations can be written interchangeably. So I'm going to write this log as an exponential. My base is 3. And the value of my exponent is the value of the log. Remember, a log is an exponent. So my power is a 2. And according to this equation, this expression is equal to x minus 5. So I'm going to rewrite from a log into an exponent. And that's what I've done here. So now all I have to do is to solve for x. So 3 to the second power is 9. And 9 is equal to x minus 5. Simple one-step equation here. I'm going to add 5 to both sides. And I get that x has a value of 14. That's it. If you can rewrite that equation into something that's more useful for you, that's going to help you out for all of these. All right, let's move on. Question B. Here I have that log of 45x minus log of 3 is equal to 1. Now here I have two logs being subtracted in this equation. What we want to do is to employ our log properties to combine these two logs into one. And if you recall, subtracting logs is the same as division. So that's log 45x divided by 3. So this is our equation with the property applied. So now we have one log equal to one value. And we can rewrite this again as an exponential. So my base, if there is no subscript shown, please remember that my base is a 10. The exponent here is 1. And this will equal 45x divided by 3. So now let's solve for x. So I'm going to multiply by 3 on both sides. Sure, we could have simplified, but I'm just going to go ahead and multiply by 3 on both sides. And I have that 45x is equal to 30. And last step is to divide both sides by 45. So what I have here is that x is equal to 2/3. 15 is divisible, or 30 and 45 are both divisible by 15. So I did a little mental math there. There's my solution. So we are applying properties, and then we are rewriting as exponentials. Let's take a look at the last two, and then you guys will have time to practice. Please feel free to pause anytime you need to in order to catch up with my calculations. All right, for question C, here I have that log base 4 of x squared is equal to 7. I am again going to apply the same principles. I'm going to rewrite this as an exponential equation. My base is 4, my power is 7, and that is going to equal x squared. Well, 4 to the 7th power is something. I don't know. I'm going to type it in my calculator, and it tells me that 4 to the 7th power is 16384, and that equals x squared. And how do I undo a square? Oh, we're going to do a square root. Take square root of both sides, and we end up with, oh, what do you know? This is a perfect square. Okay, so there you have it. Wonderful. Let's move on to problem D. Here again, I have two logs. I need to use my properties of logarithms to turn this into one single log that I can rewrite as an exponential. So this time I'm adding. In order to combine these two logs together, when they are being added, I have to multiply these elements this time. So this is going to be log of x times the quantity x plus 9 is equal to 1. And I would like to write this as an exponential, so I'm going to write it as 10 to the first power. Base of 10 to the first power is equal to this product. So x times x plus 9. We have to get rid of the parentheses, so we have to distribute. And we get that x squared plus 9x is equal to a value of 10. How do I solve this? Well, it is quadratic. Yes, friends, we need to put this into standard form. Let's set it equal to 0 so that we can know more about how we want to solve it. So this is 0 is equal to x squared plus 9x minus 10. And as, oh yeah, I could factor this. This is great. This is a negative 10. Factors of negative 10 that add up to positive 9 would be 10 and negative 1. So we're going to factor this into x minus 1 and x plus 10. I don't expect you guys to do this, but if you need to, just work it out. You could also use quadratic formula, completing the square. Well, I wouldn't recommend completing the square, but quadratic formula would always work. Okay, so this is not the end. We have to set these factors equal to 0 using our zero product property. There's a 0. And we're going to solve. Of course, you could do this mentally, but I want to be thorough in this video. So our solutions for this equation D are negative 10 and positive 1. There you have it. We have solved our logarithmic equations by changing them into expressions that are exponential. Okay, so it's your turn now. You are going to solve these two, You're going to solve these two equations. You're going to use your properties to combine. And then you're going to rewrite them as exponentials. Now, just one quick note here, because we didn't have this in our examples. If I have this number out front, this can become the exponent. Okay, so don't forget that power property, the coefficient in front of a log becomes the exponent here. So go ahead and work these. Pause the video. I'll give you time to start. And then I'll come back with the answers. Okay, I am back. Here is the solution for question 3A. Pause the video if you need to. And there's a treat for problem 3B. There are actually two ways that you can solve it. I'll scoot this up so that you can see them both. So method 1 uses the properties and it rewrites it as an exponential. Method 2 uses properties, but then it moves one of the logs to the other side, and then it takes the square root. So check those out. Pause if you need to. Shoot me an email if you have questions. Now you should be ready to do your assignment. Good luck.